Greetings to all the viewers. In continuation to the earlier session, we are discussing about various organic named reactions which are available at the channel called the World of Competitive Chemistry. This is the concept we are retrieving from textbook of organic named reactions, which is written by Dr. Kavitha Kotthireddy Kota. Baeyer-Drewson-Indigo synthesis. This is a topic for the session. So here, how the Baeyer-Drewson-Indigo synthesis is accomplished, we are going to discuss in detail. In this organic chemistry of indigo synthesis, this is established in the year 1880 by reacting 2-nitrobenzaldehyde as one of the reactant and 2 moles of acetone taken as another reactant. Organic scientist von Baeyer first ever synthesized indigo dye in the laboratory. Baeyer-Drewson indigo synthesis is a classic chemical reaction used to synthesize indigo dye, one of the oldest known dyes traditionally used for coloring fabrics, especially denim. Denim color fabric can be colored by means of this one. It is the coloring agent. It is the dyeing agent, right? So it is one of the oldest known dye traditionally used in the fabrics, especially denim. Okay. Synthesis involves condensation of nitrobenzaldehyde with acetone. 2 moles of acetone to be taken and the base to be introduced over there so that indigo dye will be generated. This is the way orthonitrobenzaldehyde is one of the reactant and sodium hydroxide acetone will be taken over there so that water added indigo dye formation is possible, right? So here reaction mechanism, formation of intermediates, right? So within the reaction, how the intermediates are generated, what mechanism accomplished, we will go through this one. Here the first precursor compound will be orthonitro. Toluene was taken, manganese oxide and sulfuric acid is able to convert this methyl into aldehydic one. This is the starting material actually, orthonitrobenzaldehyde. This is added with acetone compound. Whenever acetone added over there, what will happen? There is a formation of here carbon ion generated, that carbon able to bind up over there. It is the kind of aldol condensation reaction. Beta hydroxy ketone is the product. Whenever beta hydroxy ketone is generated, that will participate in a ring cyclization reaction with this nitrogen of nitro functionality. So here nitrogen pi bonded electrons of the carbon will bind up with the nitrogen so that pi bonded electron shifted towards the oxygen, so you can establish a 5-membered ring system. So that water will be discarded in between these two nitrogen and carbon. Newly formed bond is converted into double bond with the nitrogen positive charge. O-oxide will be there. The pi bond is moving back and this alkaline condition will abstract the proton from this 1, 2, 3, third carbon atom, so that here the pi bond restoration over this carbon-carbon bond, and here the pi bond is moving in order to satisfy the valency of this nitrogen. So that N oxide will be originated. Here the hydroxyl remains and you can establish the aromaticity within the molecule with the substitution of acetyl over position number 2. So whenever this is the case, there is a alkaline medium, right? That's the reason why hydroxyl group having provision to bind up at the position of carbonylic carbon atom. Nucleophilic addition you can designate. Whenever nucleophilic addition is possible, the pi bond is moving towards oxygen, O negative will be generated. O negative, when back polarized, the entire bonded electrons are moving over there, so that here the entire group is discarded. Here the establishment of double bond and already ketonic group is there at this position. So this is a new compound originated that further go for the hydrolysis. Whenever hydrolysis is carried, so the double bond will go for the addition with water and that hydroxyl and hydrogen upon this olefinic double bond, so that addition simply hydration we can mention. So that hydrated product will go with the reaction of with respect to this nitrogen alpha hydrogen taken by hydroxide ion. When hydroxide taking alpha hydrogen, this sigma bond is moving over there, so that pi bond formation. And here the ketonic bond is moving backside, so that negative charge formation is possible. Whenever this is the case, another molecule of the same one, this is the intermediate which you already know, right? This will go with the reaction with this one, so that both are able to form a bonding in between by the condensation process. Both are condensed so that indigo dye formation is possible. Here is the kind of ketonic moiety. Here is the kind of ketonic moiety. In between these two, carbons are joined with the olefinic double bond. This is the way entire process of indigo dye formation is possible, starting with orthonitrophenoldihyde treated with acetone under alkaline conditions. Alkaline conditions are very driving force in order to achieve the entire product. Every step, alkaline condition is most important to move forward this reaction, right? In order to understand the reaction examples with respect to this indigo synthesis, mixing reactants are required like orthonitrophenoldihyde to be added with acetone. Suitable solvent like ethanol are required, and sodium hydroxide, important factor over there. Aldol condensation reaction will initiate the reaction. This synthesis is initiated by aldol condensation. Reaction conditions: to maintain the reaction, temperature must be optimized and intermediates must be isolated. After the reaction, indigo precipitate as a blue solid from the solution. It is the blue color pigment which is solidified within the reaction only, so that blue coloration is possible after synthesizing this indigo dye. Purification. Washing with water thoroughly and precipitated indigo can be taken. To remove the impurities, recrystallization is the best method. Dry that one and pure indigo dye will be manifested. Simply, I'm taking another alternative mechanism. Here is the carboxylic acid. At the other position, I am having NHCH2COOH. This is called alpha amino acid. Sodium hydroxide is a suitable alkaline medium. 200 degrees centigrade is operated. So that ring cyclization for here C double bond O, C double bond O, OH will be originated. Decarboxylation if taken so that the molecule will be dimerized and there is a formation of indigo dye is possible. Indigo dye got highly stabilized because of the hydrogen bonding vicinity. Here NH proton will having strong affinity towards this oxygen atom lone pair of electrons so that you can achieve the intramolecular hydrogen bonding in the two edges. That's the reason why molecule will be more stable for this coloration. Practical consideration: control the reaction conditions. Temperature maintenance is very essential. Concentration to be maintained. Base is very essential to add. And the time required for the synthesis of indigo is also optimized. Handling the intermediates. So here, in order to achieve this product, the multiple intermediates taken part of this reaction so that controlled conditions we need to maintain in order to prevent the degradation. Rather than the expected product, you may go with the another side reaction giving rise to another byproduct also. In order to avoid such a degradation, so controlled conditions to be maintained. Historical significance. Baeyer-Drewson-Indigo synthesis. This is the most historical in nature. Adolph von Baeyer and Viggo Drewson in the 19th century, they established this kind of indigo synthesis in the field of organic chemistry and dye industry as well. They provided the synthetic route for the indigo synthesis. Indigo is naturally extracted from the plant actually. Apart from that, alternative method also generated within the laboratory by these scientists. They successfully achieved the synthesis, right? So that was traditionally extracted from the plant like Indigo fera tinctoria. Directly you can extract and you can use in the textile industry. Apart from that, this is the synthetic route they established in the year 19th century. Sorry, in this 19th century, they established this new way of laboratory protocol. So after synthesizing this one, let me go for the application. Obviously, being it is a coloring agent, textile industry will utilize this one for the coloration of the textiles like fabrics, clothing, and dyeing of denim is especially required by this indigo. Biological research, there also we can apply biochemical assays can be performed by means of this indigo dye, and various biochemical screening studies were carried. 2 moles of acid chloride accorded indonaphthalene benzene. So further boration of this compound to be taken. Diborolated cross-conjugated monomer will be generated. That is working like a semiconductor. So that is working like a semiconductor in the polymer synthesis. So it is also the versatile application for this indigo dye. Reaction of indigo dye with acid chloride is giving rise to a strong annihilation. You can clearly observe. Whatever indigo taken and added with acid chloride like this in the presence of potassium butoxide, potassium butoxide, which is a strong base, and there is N acylation. You can clearly observe N acylation. Whatever N acylation product generated, that is having a kind of field effect transistor applications are accorded. This is the material chemistry application in the field of electronics. Transistor applications also accomplished by N-acylated product. If you are taking this indigo dye and treated with this length of how many carbons? 1, 2, 3, 4, 5, 6 carbons. Hexanoyl chloride will be taken and potassium butoxide is a strong base, so that in acylation taking place over there. Transistor applications are given. This is the electronic material chemistry application, so that it is most valid synthon. And I'm taking this para-aminotoluene. So para-aminotoluene further go for the nitration. Obviously, simple nitrating agent will be taken for this nitration process. Later on, this wherever ammonia is there to be replaced with the bromo functionality. And whenever a methyl group is there, supposed to be oxidized, mild oxidation, or as controlled oxidation, giving rise to a kind of aldehyde. This aldehyde with NO2 is the precursor, although nitrobenzaldehyde is the precursor for this indigo synthesis. You may opt entire process of indigo synthesis directly. I got this indigo over there. This is the molecule said to be indigo. The whatever molecule indigo got synthesized to be treated with this molecule called acid chloride. So that acid chloride can be generated by means of the carboxylic acid and halogenation, giving rise to acid chloride. The acid chloride and indigo dye supposed to be blended, mixing of these two compounds, giving rise to highly complicated molecule. You can notice that is a fully fused one, polyannular system, fully fused one is originated. Further boronation. So this is said to be boration. So further boration is giving rise to a molecule which you can notice as a final product. This is of synthetic importance. This is of synthetic importance in the industrial process. So this is the most important process for this indigo application. This is the perspective regarding indigo applications, right? In summary, Baeyer-Drewson-Indigo synthesis is a classical and historically very important method producing indigo dye from orthonitrobenzaldehyde and acetone as well, right? The reaction facilitated by the base catalyzed conditions and proven way for the large scale production of dyes in the industry. They may be utilized in the pharmaceuticals and also in the textile industry, even in the dye chemistry. So here they are versatile in the organic synthetic chemistry as well. This is the way the entire process of indigo synthesis was accomplished, which is in specific Baeyer-Drewson-Indigo synthesis, right? So in the next session, we will go with the Baeyer-Valigal oxidation. Again, it is the organic named reaction. So we will discuss in the next session. Meanwhile, you can subscribe and continue the channel for watching the entire series of sessions which are available based on organic chemistry. So you will definitely go for the success in the chemistry field. Thank you very much for your patience.